In the previous lesson, we talked about a conditional statement, the if and the then statements. Now, we know that the hypothesis is the if part, and we know that the then part is what we call the conclusion. Now, we're going to be talking about the truth value of each conditional statement. So, determine the truth value of each conditional statement. What I'm asking on that one is this statement true or is it false? Now, if it is true, so reading the instructions, it says, if true, explain your reasoning. If false, give a counterexample. So I'm going to determine the truth value of the conditional statement. If it is true, I will explain why it is true. If it is false, I'm going to give a counterexample. Now, a counterexample is basically a case where the if part, the hypothesis is true, but the conclusion is not. So once again, the counterexample is when the hypothesis is true, but not the conclusion. So I'm going to try to think of a number. I'm going to try to think of a counterexample. Let me identify the hypothesis and the conclusion. In this case, I see my words if and then. If a number is divisible by 3, then it is odd. So I see my if and my then. I'm going to identify my hypotheses. A number is divisible by 3. My conclusion in this case is it is odd. Now, divisible by 3 means I can divide it by 3 and I do not get a decimal. That's what divisible by 3 means. So I'm trying to think of a counterexample. No, so in order for this to be false, I'm going to think of one case when this is not true. And then the counterexample is the hypothesis has to be true, but the conclusion is not. So I want to think of a number that I can divide by 3, but it is not odd. So once again, I want to think of a number that I can divide by 3, but an even number. I have many choices in this case. I could think of the number 6. I'm just going to give the number 6. 6 is divisible by 3, but it is not odd. Once again, if it is false, I want to give a counterexample. And a counterexample is an example when this is not true. And this is not true if the hypothesis is true, but not the conclusion. So that's it. I just showed a counterexample. So if false, give a counterexample. There are cases when this is true. I could think of the number 9. Yeah, it is divisible by 3 and it is odd. But once again, I'm not asking for you to give me an example when it is true. I'm saying if it is true, tell me why. If it's false, show me one time when it doesn't work. Let's take a look at number 6. If an angle is 90 degrees, then it is a right angle. I see my words if and then. I can identify my if and my then because that's going to help me identify the hypotheses and the conclusion. Remember, the hypothesis is the if part, the conclusion is the then part. I'm going to start thinking of a counterexample. I want an angle that is 90 degrees because I want the hypothesis to be true. I want to think of a number that is 90 degrees, but it is not a right angle. I'm trying to think of a counterexample. I'm trying to prove this wrong. So I want to think of a number that is 90 degrees, but is not a right angle. I cannot think of that because I know 90 degrees is a right angle. So there's no way I can come up with a number that is 90 and not a right angle. And the reason why, because like I said, 90 degrees is a right angle. So I'm just going to say I can't. And the reason why is I'm just going to write definition of a right angle. Right? A right angle is 90 degrees. I cannot think of this thing being false. I cannot think of a counterexample. Therefore, it has to be true. It is true. I just wrote a definition of a right angle. Now, let's take a look at question number 7. If you live in Hollywood, then you live in California. I can see my words if and then. I like the words if and then because they help me identify the hypotheses. The hypothesis is the if part. And I can also identify the conclusion. That's the then part. I want to prove this wrong. I want the hypothesis to be true, and I want the conclusion to not be true. So I want something that is Hollywood. I want to think of a city that is Hollywood, but not in California. I can use Google, I can use maps, I can use my knowledge. Now, if I find Florida right above from Miami, north of Miami, there's a little place called Hollywood, Florida. I was looking for a place called Hollywood that was not in California, and I just found it. So I'm going to say, you can live or you live in Hollywood, Florida. Once again, I'm showing a case where the if part is true, but not the then part. I want the hypothesis to be true, but not the conclusion. Just show an example when it is not true. So now let's move on to question number 8. If an angle measures 35 degrees, then it is acute. I see my if and my then part. They help me because the if part does the hypothesis. The then part, it's the conclusion. I'm trying to think of this, think of a counterexample. I want to prove this wrong. I want to think of an angle that it measures 35 degrees. I'm thinking of an angle that is 35, but I don't want it to be acute. Now, acute angles are any angle that is less than 90, between 0 and 90. So, 35 degrees, that's an acute. Because once again, I said an acute is between 0 and 90. So it's more than 0, less than 90. Right? 35 is an acute. I cannot think of a counterexample, so I'm just going to write definition of acute. An acute angle is a number, it's between 0 and 90. I didn't write definition of 35 because 35 is just 35. All right, I'm writing a definition of acute. An acute angle is between 0 and 90. So that's what I'm asking for the truth value of each conditional statement. Notice how I'm not asking for a true or false word. So don't just write true or false, right? If it is true, tell me why it is true. If it is false, show me one time when this thing is false.